Okay, so last time we learned about the buck converters, right?
Yeah.
Which is power supplies, right?
Mm-hmm.
Okay, so this one is changing the voltage into the current. You trade the voltage for the current. Let's test it one more time. So here we have the ammeter. Switch it on. Yeah. And increase the duty cycle. And we can see, yeah, like right now we have 3 amps out and we are putting like 1.2 amps in, right?
Yeah. Mm-hmm.
Remember I told you what the problem is?
Yeah.
Yeah, touch it and you will see the problem. So the diode is the weakest spot on this schematic, yeah?
Yeah, it's getting hot.
Yeah, we have like a 5 amps diode and we cannot really push more out. Maybe I want more than 8 amps. I mean, you can't even take 5 amps because the diode is getting very hot.
Mm-hmm.
So what is the solution in order to output more current? To replace the diode with what? Because the diode is the weakest spot here.
So you cannot replace the diode with the
biggest one?
With the biggest one, yeah.
Yeah, but still, maybe I want 15 amps, maybe I want 20 amps out. You know what I mean?
Mm-hmm.
And on that point, the diode become very big. So the diode is not really a solution. Also, have in mind, you lose, yeah? You lose like on this diode, like Schottky diode, you are losing like 0.2 volts, right?
Mm-hmm.
Yeah, that means you are losing current there. I mean, that's the reason why it's getting hot. So we can replace with what, this diode?
I don't know, because you need to
Yeah, you need to close the circuit, I understand.
yes, but you also need to have the current in that way.
The current flow, yeah, when the coil is bouncing back, is on this direction. You understand? When the coil is bouncing back.
Mm-hmm.
So it's bouncing back with plus here and minus here, right? You remember?
Yeah.
Yeah. So that's the current flow. What about another MOSFET? When the duty cycle is switching this MOSFET off, we can switch this MOSFET on, and we are closing the circuit.
And then when this one is switching off, that one is switching on.
Exactly, to charge the coil. What do you think about that? Okay, so basically that's the schematic.
Mm-hmm.
We are replacing the diode with a MOSFET. Now let me tell you something about the schematic.
Yeah.
So usually on the schematics, when you don't want to use lines and pass the tracks, yeah, what they are doing something like that. And we know, yeah, here we have minus. We know, yeah, so this is like ground sign. So we know every pin is connected together to minus.
Okay.
So in this way, we can connect here that capacitor, which has to be, remember, on the switching MOSFETs.
Yeah.
So now it's more clean. The schematic is more clean.
So you have that capacitor connected to the ground.
Exactly. You see?
Yeah.
That means it's connected to the ground. You will see the sign like that, or you'll see it like that, which is symbolized like the ground.
Mm-hmm.
Yeah?
Mm-hmm.
So we have two MOSFETs, and we have the output of the PWM generator.
Yeah.
Yeah?
Mm-hmm.
You see, in this way, when the coil is bouncing back, yeah, with the minus here and plus here,
yeah,
we can discharge the coil through the MOSFET. Okay, and the circuit, it will be like that. Okay?
Mm-hmm.
Clear?
Yeah.
That's how the power supplies, like all the power suppliers are on those days.
Mm-hmm.
And they are using two MOSFETs. So every power supply from a laptop or any other device, this kind of design with two MOSFETs.
All right.
Instead of using a high amperage diode, which probably is expensive, they're using a MOSFET.
Mm-hmm.
Now it's one problem. And here, Here is a catch. I was very disappointed to go online and actually to see no one, I searched on Google, no one is using signal inverters. Why you will need a signal inverter on this schematic? Okay, let's say we are connecting the gates together and to the PWM output here. This is the output from the PWM generator here. Now, basically, when it's on, when it's on, you can say like it's 1 or 0. 0 means 0, 1 means high,
Yeah.
Or you can say high and low, So when the signal is high, what will happen? This MOSFET, it will drive the power, right?
Okay.
But also this MOSFET, it will drive the power. Basically, you short the power supply, So here is high, right? So when it will be high, both MOSFET, it will drive the power. That means you short exactly the plus line with the minus line. Right?
Okay.
Yeah? Because both MOSFETs, they will have 0 ohms. That means you have a wire between the plus and minus. So till here is clear?
I'm not sure.
Okay, what you are not sure? The way how the MOSFET works when it's high, that means you have plus 20 volts on the gate. That means the MOSFET, it's on.
It's on.
Yeah, it's
Yeah.
driving the power. You have two MOSFETs, Here is wire, MOSFET connected to ground. That means you short the plus with ground.
Okay.
It's clear?
Yeah,
You
yeah.
don't have nothing with you. When the MOSFET is on, has 0 ohms.
Yeah, and that one, the second one, it's on as well.
Yeah,
so
exactly.
They are on at the same time.
Exactly.
And they don't need because.
No, they don't have to be on because this is a short.
Yeah. Okay.
Yeah? So what actually I want to happen?
You want that
One on and other one
yes.
off. Exactly.
But how do you do that?
How can I do that? You see, that's why I was so disappointed to see on Google. Yeah?
Yeah.
If we are checking now on Google, you'll find no signal inverter. You'll find, you know what? You'll find like PWM IC or chips with two outputs. And
Two outputs, I mean,
yeah.
connected one on there, one on the other one.
Exactly. So this signal,
Yeah.
it's the phase of the second signal. It's with 180 degrees. That's mean opposite. Yeah. So one, you connect this. I mean, this one can be connected here straight away,
Yeah.
straight here.
Yeah, but it's simple, and you have another output to connect the other one.
It's simple.
I mean,
it's,
yeah.
Oh, you know what? I hate this. I hate when people are telling me use a chip.
Yeah,
I hate
it's
this.
simple. I mean, what's the point to have
It's
like
not simple.
something else?
It's stupid. It's pointless.
When you can have two outs and connect one on that MOSFET and one on the other MOSFET.
Exactly. That's how you will find on Google. You'll see that.
Yeah, but that's the simple
It's
way.
not because it's forcing you to use a specialized chip IC. So you have something special for this power supply. I don't want to be forced. I want to be free to use any PWM generator. So what do we need? Yeah? Don't forget what do we need. So when this is on, yeah?
Yeah, the other one
I
must be
want
off.
this to go off.
Off, yeah.
Yeah. That's what I want. So I need the C signal to be 180 degrees compared with the top one. So how we can do that? Think. That's all what you have to do. Think, because you know how. You know how. That's the thing. You know. So what components we have to use in order to achieve this? Yeah? It's simple. It's so simple. It's so simple, actually, no one is using
Wait.
it.
Wait a minute. Yeah. You can use a coil?
No.
No, you cannot.
Coils are complicated. They bounce back, you know,
Yeah.
not,
All right. They
are not friendly.
I don't know.
Look, so when this is on, yeah,
Mm-hmm.
when this is off, when this is off, I want this to be on, right?
Yeah.
In order to make this MOSFET on, all I have to do is to use a resistor. Yeah, I will jump here. Yeah, I will jump here to plus. So I switch the MOSFET on, but having a resistor here, it's always on, right? Connecting the gate to the plus, is this MOSFET will be always on.
Okay.
So how can I switch this MOSFET off then? So I just create a condition for this MOSFET to be on when it's not off. Yeah? Because that's how you are doing it. First, let's assure this MOSFET can be on.
All right.
Then,
so now that MOSFET,
yeah,
it's always on.
yes,
And now you have to use something else
yes, to switch it off.
to switch it off.
Yeah.
Use another resistor to the ground.
So you create a divider. So you will not have 12 here, you'll have 5.
Oh,
You solve nothing.
true.
You need something which can interact with this signal to be opposite to 180 degrees.
Mm-hmm.
What about another MOSFET?
Another one.
Yeah. So check here. Yeah. Another MOSFET here. And here we'll have the drain. Yeah, because channel N MOSFET. Yeah. This connected to ground. Yeah.
Okay.
And this one, you have the gate, right?
Yeah. Connected where?
Here. So what will happen? When this MOSFET is on, this will be on, obviously, because it has the same gate signal, right?
Yeah.
But when this is on, yeah?
Mm-hmm.
When this MOSFET is on means is connecting the gate.
To the ground.
If the gate is connected to ground, that means this MOSFET is off. You understand?
Yeah, but you see, you complicate it too much.
I-
Put a resistor. Put another MOSFET.
I didn't use a second MOSFET and a resistor. That's all what I used. And I have a 180 degree signal here.
Yeah, but now, I see the easiest part. Like,
Yeah,
Just-
what is the easiest?
the easiest part, like how they are doing it. Just
You
take
don't
out
have.
another out and that's it. You don't use the resistor MOSFET.
But you don't have. That's all what you have. You have one output. That's all what you have. You have one output.
Okay.
You're telling me now I have to buy a chip to have a.
Oh, okay.
You can't let the electronics to control you.
You have to control.
You have to
the
exactly.
electronic. Okay.
So let's make this clear, yeah.
Yeah.
So when this is on, yeah. So here is the line.
Mm-hmm.
So when this is on here, yeah. This MOSFET it will be on, yeah. It will charge the coil, right?
Yes.
When this is on, yeah, is the same track. This MOSFET it will be on.
Yeah.
This MOSFET being on, that means it's 0 ohms between the drain and the source. That means this gate is connected to ground. If the gate is connected to ground, this MOSFET is off. Is clear?
Mm-hmm.
Yeah?
Yeah.
Good. Then the cycle is changing. This is going off. Yeah?
Yeah.
Now it's off. When this is off, this MOSFET is off, right?
Yes. The other one is off as well.
If this is off, that means the transistor
It will drop the power to that gate. And
exactly.
It will turn that on.
Exactly, it will turn this on. You see? You see what I mean?
Yeah.
It is clear?
Mm-hmm.
No, I don't think it's clear. No, I want you to tell me this is 100% clear and you have no confusion.
I understand.
Yeah?
Yes.
So you agree this it will work?
It will. It will work. Yeah.
Yeah, but you see what simple is to create an inverter. Not an inverter, an inversor or I don't know how it's called in English, you know? It's just a circuit which it will change the phase of the signal, or it will invert the signal from minus to plus, from plus to minus. Huh?
Yeah.
And you'll find nowhere this kind of schematic, yeah? Using just one output from the PWM signal generator. On Google, you'll not find it. Because I checked and I said, you know, let me see how the other people are doing it. But it looks like everyone is doing, like buying chips and using dual outputs. So what do you think about this schematic? Can we do it?
Yeah.
Yeah, let's do it. Let's do it. So what do I want to change from this, yeah? And it's
Yeah.
not because of the power. We have here two MOSFETs. I bought it from eBay. Now, this is like a 10 amps MOSFET, I believe, 10 or 20, I don't remember. Those are 100 amps each.
Wow.
Yeah. And we don't need 100 amps, but the internal resistance is 0.00 something.
That means close to zero.
Yeah, that means less heat, because we don't have big heat sinks. So that was the idea why I bought the MOSFET. We don't need that kind of amps, but we need less heat on the heat sink. So if anyone is looking to buy those MOSFET, I don't know, I pay like £9 for 5 MOSFETs, 104 amps, 40 volts, and very low gate voltage, like 5 volts. Yeah. Yeah, but it's not necessary, but just, you know, to keep the things cool. That's the last things what you want to, you know, to have problems with this, with small heat sinks on, you know, high current MOSFETs. So let's do it. Let's replicate the schematic.
All right. So we need to take the diode off
Yes.
and replace it with the MOSFET.
You take that MOSFET out. You have to rebuild everything.
But why you take that MOSFET out?
Because we have another two here. I want those two new MOSFETs. Yeah, there.
Yeah, but we need another one because there are 3 MOSFETs.
Oh, no, I'll give you.
Okay.
The third one is a small one.
Okay.
Like last time, yeah? I'll give you that one also. Now check here. This is from, we used it last time, you remember?
Oh, with the resistor as well?
Yeah.
Okay.
Okay?
Yeah.
But what do I want from you? I want a clever, clever design. You know, I don't want to see, you know, spiders. I want everything aligned nicely. Like transistor like that, you make everything nicely.
That will not gonna happen.
Why not?
No.
You're clever.
All right. Let's see.
So all done?
Yeah.
You sure it will work?
Everything is in place. Comfort the schematic.
According with the schematic?
According with the schematic.
Okay, we'll take the power supply. You know, it's not like I don't trust you, but let me limit the current, yeah? Let me limit the current. 1 amp, yeah.
If you
It's not like I don't trust you, but
you don't trust your schematic?
I do.
All right.
Okay, let me reset this. Good. No. Just set to 0. Because you don't know what will happen. Yeah.
There
So
is
now, yeah,
Power on?
Yeah. And raise the current. Yeah, we have light. And yeah, we are getting onto the limit. Yeah. Let me raise the power supply current.
All right, let me put this to 0. And we have picture! No, we have light.
Let me increase the current. Okay, let me raise the voltage a little bit. Let me raise the voltage, yeah. So let's reach like 10 amps on the output, and if we are reaching 10 amps, that means all done.
All right.
Yeah, do it.
On.
Yeah.
Three, 4,
Yeah.
5, 6, 7, 8,
Eight.
9.
And we have a current limit.
Yeah.
Yeah, raise the voltage. Try one more time.
All right. Here we go. 2, 3, 4, 5, 6,
Six,
7,
seven.
8, 9, 10.
10 amps. Yeah, we seen 10 amps. The problem is, yeah? The problem is, let's raise the current to like 3 amps, yeah? 3 amps on the output, you see?
Mm-hmm.
So what you put in? You put in like 800 milliamps, right?
Yes.
So how many times you get the current out?
Like
Like 4 times?
4 times, yes.
Okay, let's go to 10 amps and see how many times you are get that current out. 8.
9.
So we are putting in 5
4.
amps and we are taking out
10.
10.
Yes.
So it's only double.
Double.
Why
Yeah.
do you think that's happening?
So when you put lower, you get high amps. When you put low
Yeah.
current,
You get a better efficiency. That's what you say.
Oh yeah.
When you get a lot more compared to what you put in,
Mm-hmm.
it's called efficiency. So basically we have higher efficiency,
On the lower current.
low current output compared to high.
Yeah.
Because you start losing. You're losing the coil. Check the coil. It's nearly, you can keep the you can see?
Yeah, it's very hot.
Remember when I told you last time, the diode and the coil?
Yes.
Yeah, I mean, yeah, you can see it's proper hot.
Mm-hmm.
So proper hot means higher resistance, means you are losing current.
Yeah.
On the other thing, you lose current on the MOSFETs.
Oh, these are getting hot
Yeah,
as well.
be careful.
Oh, yeah.
So that's the efficiency.
Mm-hmm.
Okay?
Yeah.
So everything is clear?
Everything is clear, yes.
I will not gonna insist with this specific power supply. We should do it because it's used everywhere. But we prove the point. We invert the signal to have the second MOSFET acting as a diode. So from the next time, we're gonna move to something more interesting.
More interesting means more complicated. A bit, huh?
I'm not sure. Maybe we should spend more time on this because we can add like precise voltage output. But we already done that with the last.
Yeah.
Yeah, it's the same way. On the same way you are doing it. Current control, voltage control, you are doing like the same way like last time.
Mm-hmm.
So I will say, starting from the next time, let's move to high voltage switching power supplies.
Okay.
Yeah,
I don't know what that means, but I think I will find out.
Like any power supply which is connected to 220 volts or 110 volts.
Mm-hmm.
Yeah?
Mm-hmm.
They are designed in a different way.
Okay.
Will be more interesting.
Wait.
We're going to start using transformers.
Oh.
Hmm?
No more coils. Get back to big things, transformers.
Okay?
All right.
Good.